Now the numbers are going up.
Good morning, good afternoon, good evening, everyone. Thank you for joining us today. We're going to wait a few minutes just for everybody to join, and then we will get started. Okay, well, as I said, good morning, good afternoon, and good evening, everyone from wherever you are joining us. Thank you for coming to today's webinar on managing the connected home, discovering device capabilities using USP. My name is Jason Walls from QA Cafe, and I am the chair of the Connected Home Council at the Broadband Forum. And we've been making an effort to put together a series of more in-depth webinars on USP, TR369, and the evolution from TR69 and the details around that evolution and the new benefits of USP and how you can actually implement them. So this is going to be fairly technical and talking about some of the underlying features of the data model and USP. So I just wanted to say that ahead of time that if you're completely unfamiliar with TR69 or TR181, those documents that we'll be talking about specify the capabilities of a device that is represented by a management protocol like USP. So we're going to be talking about the advantages that have been added to USP to make discovering those capabilities easier. And that's what Daniel's going to be talking about today. So I'll introduce Daniel. So Daniel Egger is a principal software engineer at Axiros. He is also the data modeling project stream co-leader at the Broadband Forum. So he helps us develop the data model, add things to it, and write all the juicy XML that goes into making it what it is. So he definitely knows the most about this, and he's from Axiros. They produce a number of management software suites and other tools that you can use to help manage your device and your network. And so they've been sponsoring this webinar, and we thank them for that very much. But Daniel knows the most about this, so he's going to give you a nice in-depth look at how this all works. Just a couple of other things. So we're using Zoom for this webinar. The Q&A at the end, we want to try and we have a lot of people on the webinar today. It's pretty huge, so we want to make sure we get to as many of the questions as possible. If you can type them in as you're going, that would be great, so that we already have them in the queue for the Q&A section. You want to put them into the Q&A box in your Zoom control panel rather than the chat, because we won't necessarily see those. And if you have trouble seeing this at all, it's mostly going to be slides, so I don't think you'll have a problem. But if you do need to adjust the Zoom settings of Zoom, you can do that at the top and make it a little bit better fit depending on what kind of screen you're on. All right. So without further ado, I will give things over to Daniel.
Thanks a lot, Jason, for the introduction. All right, let's jump right in. So as Jason already mentioned, we are going to talk mostly about data models today. So a few things that I'm going to cover here is where do we come from the BBF data model? So what's the evolution? How did we use it in TR69? What can you do with TR69 and the data models? And then, of course, we're going to talk about what new features we have with USP and what that means for the data models themselves. And then we are also going to explore a little bit the new capabilities that USP gives us, just to have some context, what that means for us and for the data models. And then we are diving into the main topic of this particular webinar, which is what new features can we use with USP in order to figure out what the device supports and make that basically on the fly instead of relying on its existence. So let's see where we come from. So in general, data models describe the functionality of a device, which means that you have this expression language that allows you to say exactly what kind of objects do you have in your device, what kind of parameters do these objects have, and how do these objects correlate to each other. So it's basically a tree of structured information, and there's a modeling language around it that allows you to describe how this works. The broadband forum itself is also very deeply involved in providing data models for a lot of different use cases already out of the box. So basically, if you want to use a data model, we have a couple of existing data models that you can simply rely on, and they're being developed by, well, the data modeling stream inside the broadband forum. So some of these data models are tier 181, issue 2, which is a device data model. We have tier 104, which is a voice service data model. There's tier 135 for set-top boxes. There's tier 140 for storage devices, and there are a couple more for special use cases. So basically those already exist, and if you have a product that wants to use some of those objects defined in these data models to describe some functionality of your device, they are there and can be used. So there's also this document that's called tier 106, which specifies exactly how these data models are structured, how they are defined, what the capabilities are. So basically the schema of the data models and how you can use them. And that's very important because this is also used by various tools in order to validate the correct use of the data models. So one thing that we had, so we've been using those data models and the tier 106 definition for quite a while now, and with tier 69 mostly, and it all works fine. It's deployed in the field. It's on billions of devices, and a lot of people know how to use those. But with tier 69, there actually were some limitations. So for instance, most of the data we have in the data model is really just data. So basically, it can be used to configure a device. It can be used to retrieve information from a device, like system information or monitoring data. But most of the objects we have in the model just data, and what that means for the particular device is up to the device itself. But there were no actions or any other activities that you could trigger on the device, with a few exceptions. For instance, diagnostics, there was a special mechanism where you could set some parameters in order to trigger diagnostics, and then you would get some event back when the diagnostic finished, and then you could basically read out the object again to get the diagnostic information. But basically, there are no activities directly in the data model. It's all just data. And in tier 69, we had special RPCs and events that were sent with the info messages that would allow you to actually interact with the device in more meaningful ways. So for instance, if you want to do a software upgrade, you could issue a download command, or if you want to factory reset a device, there's a factory reset mechanism that would allow you to actually interact with this device in a specific way. But those were quite limited in a way because they were defined only by the device. There were a couple specific ones that are part of the Tier 69 specification, but there are lots of vendor-specific extensions, and you basically cannot see exactly what is supported by the device if it's hidden behind an RPC, because there's no way to figure out from the device or query the device for the supported RPCs. And also the event codes. There are a number of predefined ones. You can also have vendor-specific ones, but you cannot attach any information to it. So basically, the device will tell you that something has happened, but it can not give you any specific details, and it's up to, in that particular case, the ACS to figure out what actually happened in the background and retrieve the information by just using this event code. So in Tier 69, we had a few RPCs that were capable of interacting with the data model. So those were get parameter names, which allow you to, well, basically traverse the whole tree or just a subtree of the data model and figure out what parameters are currently instantiated in the device. We will see in a second what that means. Those abilities were very limited. So get parameter names really just gives you the names of the objects and parameters without any additional information what that means. And then there's also get parameter attributes, which allows you to query some meta information about those parameters, but it's also somewhat limited. Then of course there's the get parameter values, which allows you to retrieve the values. And yeah, for RPCs, we have get RPC methods, but it's basically just a string saying, you know, you have a method like download, upload, but there's no way of figuring out how they actually work. And those are more or less the only things that you can use in order to figure out what the device supports. And as I just mentioned, those RPCs, get parameter names and get parameter values and get parameter attributes, really only work on instantiated data. So this means that we need to get a little bit into what that actually means, instantiated data model, and what we also support in USP, because the instantiated data model is not necessarily the information that you want to have if you're interested in figuring out what the device supports. So we have a separate slide specifically for that. So we are dealing with two different terms here. One is the supported data model, and the supported data model is a representation of what the device or the agent, the implementation actually supports, what it is capable of representing. So that means that you can have a lot of functionality on the device that's not actually used. But with USP, and we will see how that works in a bit, allows you to actually figure out what a device supports. Versus the other one is the instantiated data model. That is the data model that is currently active on the device. So if you are asking a device, be it with Tier 69 or USP, what is currently in your data model, what you will get is the instantiated data model. This also means that if you have some functionality on the device that you in principle could support, but it's not active right now because, for instance, you don't have the network interface enabled, or yeah, no one created such an object, then with Tier 69, you're basically blind because you cannot see that there actually could be such an object because it's simply not there. And also you cannot see what's behind that object. So in a hierarchy, you typically have multiple levels of objects, and if one object is missing, like a Wi-Fi device, then you can also not see the information that's associated with that device. So even if you knew that there could be a Wi-Fi device, you don't know what's exactly supported by this particular Wi-Fi device. So in USP, we actually try to do things a little bit differently in order to give us the flexibility to actually ask the device what what we could do. So in order to get to that point, we changed the way that USP works quite a bit from the way that Tier 69 works, by relying much more on the data model than Tier 69 did. So as I mentioned before, we have these the RPCs, which were defined in the Tier 69 specification. You could also have vendor-specific ones, but we leave those aside for now. But in Tier 69, in USP, we actually reduced the amount of specific messages that we have, the protocol-defined messages, and instead moved all of the special commands and events, so most of the things that would be handled by RPCs in Tier 69, directly into the data model. So basically that means if you have an access to the data model, you can, to the supported data model, I should say, you can directly figure out what the device supports, also in terms of, let's say, custom RPCs or custom commands, as they're called in USP, and also the events that you could use. But since Tier 69, of course, cannot deal with those new capabilities, and we still wanted to use as much as possible from the previous data models to have them as compatible as possible with USP. So you can basically use all the workflows that you already have in place and the mechanisms that you have in place. You can basically translate all your use cases that you have in the Tier 69 world directly to USP by having this compatibility. So what we did in the project stream was to split the data models into 3 parts, which is the common part, the Tier 69 part, and the USP part. So the common part is basically everything that was previously in the Tier 69 part, but it removes all the Tier 69 specifics. So the diagnostics mechanism has been revamped. That's directly in the Tier 69 specific part, or CWMP as we call it in this particular case. We removed, for instance, the ACS specific information like the management server. So this is also part of Tier 69, but everything else that you could find in, for instance, the Tier 181 data models or any of the other service data models, that has moved to common and is available in the exact same way in USP. But in addition to that, we had to add some protocol-specific features, and we had to remodel those RPCs that we removed, like the factory reset, firmware update, download. So those have all been translated into data model objects, which are only available in the USP data model. And those build on each other. So both, if you're looking at the Tier 69 data model, then you can see everything that's basically in Tier 69 in common. And if you look at the USP data model, it will automatically pull in everything in common as well. So you can see all the contents of USP and common. And if you look at the report tool output, it will show you exactly what's in there. And it will also slightly change the markup, the annotation, what's displayed in the particular data model. So since we are now talking a little bit about USP, let's have a short interlude and explain a little bit what new things USP brings to the table here, which is quite important to understand what the new flexibility means and what you can do with data models in this. So as I mentioned, we have this base set of messages and events, which are directly defined in the USP protocol. So there's nothing in the data model needed for that. The data model defines everything else. So basically the special RPCs and the custom ones, the commands and the events have now all been moved to the data model elements. This also means that we had to change a few other things that are related to that a little bit. So since there are no fixed commands and events anymore, you don't have those available directly as messages, but we needed to introduce an additional mechanism that would allow us to invoke those or use those. So basically we have those new subscriptions and asynchronous commands, and those are also controlled via the data model. So basically if you want to have some of these new events that are now described in the data model available at your controller and be notified if something changes accordingly, then you have to create a subscription object in the data model that will give you this information when that particular event occurs. And since we now don't have these asynchronous methods anymore, or RPCs anymore, we also have a special table in the data model that will allow us to show the currently scheduled asynchronous methods and store them in the data model and abort them and do a lot of other interesting stuff with that. Yeah, we also added the ability to introspect and discover both the supported and the instantiated data model. So unlike Tier 69, where you can only look at the instantiated data model, we now have tools available to look at both of those. We also changed a little bit the operations. So there's a lot more things that you can now do in a single message versus multiple operations in Tier 69, which also means that you can simplify your operational workflows on the controller side quite a bit by simply doing more things in one go. And we also allow for partial success. So if you remember Tier 69, then you will know that most of the operations have some sort of atomicity built in. So if you do like a huge set parameter values call and a single of those parameters fails to set, then the whole thing would basically be rolled back and you would just get an error message, which is of course somewhat tedious. And in this particular case, USP allows you to say it's okay if this particular thing fails and just ignore it and continue with the rest. Yeah, and we also have the new add message, which actually allows us to set the object directly during the creation time. This is actually quite important because some of the ways that USP works have changed in comparison to Tier 69. So if you did an add object in Tier 69, you would basically get back the path name of the object. So you could basically in the next step set parameters in that particular object, but this is now actually combined in one add message, and most of the objects in USP are actually immutable. So once you've created them, you cannot change them again. So you need to set the parameters right while you're creating the object. But back to the important stuff, I promised you we would have a look at what we can do in USP to actually figure out what the supported data model contains. And there's this special message for that, which is called get supported DM. So this particular message allows a controller to query for any supported objects, parameters, commands, and events inside the data model. And you can actually select which kind of information you would like to have in a response. So it looks a little bit like you can see down here in green, you have this get supported DM that you can send, then you can specify object path, and they can use all of the fancy USP features. So you can also use search paths in here that basically limit what exactly you're querying for. It's probably not that useful for get supported DM, but you could do it if you wanted to. And you can also specify multiple paths in one go. So it's not just limited to a single path. And then you can specify whether you want to have just the same level in the hierarchy that you're querying for, or you can have it recursively go all the way down. And then you can say, I want to see all the commands that are in there. I want to have all the events. I want to get all the parameters that are in the objects of the supported data model underneath that path. And if you do that, then you will basically get back the requested information in the data model, including the URI of the underlying data model. So if that is supplied, you can basically look up what exactly that means, because we don't, of course, have all the details like descriptions in the supported data model of the device. But you get back the information that you requested, including pointers to the data model if it exists. And the path syntax is exactly like the one you have in Tier 106. So there are no instance identifiers, but only these placeholders in the path, which means that if you have 100 objects of a kind, then you don't get each of the objects, but you really only get everything that's at that particular level in the hierarchy. So just a single object with the index replaced by this placeholder. And it's the exact same syntax that's also used by the data models and the report. So if you look it up, you can see exactly what's what. So this works completely independently from the actually available object instances in the instantiated data model. So even if there are no objects currently in the instantiated data model, you will still get the same output and you will see everything that could be theoretically there. It also delivers some concrete information about the object accessibility, so whether you can just read it, write it, create it, delete it, type, associated commands, events, and parameters. And of course, you get all the available details that we have about those. So for parameters, for instance, also whether you can read or write them. For events, what commands, what kind of arguments you have, you can supply to them. We will all supply it with the get supported DM result. So basically what that means is that you actually don't need to guess or ask the vendor about the supported capabilities of a device. You can just use a controller, connect the device to it, and then you can query the actual device, and the device will tell you exactly what it could support, even if there are no objects currently that do that particular thing. And what you see is also what you get. So it's highly unlikely that someone implements this in two different ways. So when you actually query the information, you would get a different implementation than what would happen if you do the get supported DM. So you can really expect that if you do this querying, then the device actually knows about these objects and will be able to deal with them. It also allows you to easily compare differences in device capabilities between models, variants, environments, and or firmware versions. So as I mentioned, in TR69, you only have the ability to check the actually instantiated objects, which means that if you are in a different environment or the device has a different configuration, then you might have a completely different set of objects in that particular device with different index numbers and everything. And if you try to compare them to another device that has, again, different objects with different index numbers, it's really hard to see the differences. But in this particular case, since it's all abstracted over, you only get this identifier instead of the actual instance numbers. You can directly lay one on top of the other and see the differences in the supported data model. And of course, this also allows you more easily to compare and track the implementation against the data model report. So this is a very handy, useful thing that should eliminate a lot of problems that people are now seeing in the field when they try to deploy new TR69 devices. So the other one that we have is, since we sometimes are not interested in only what is supported, but what is actually there, there's a second command which is called message, which is called get instances, and get instances allows you to query the instantiated data model. So get instances will really give you the instantiated objects, and it will also give you the unique key parameters. So this is important if you want to use search queries, for instance, then you need to have some key parameters that you can actually use for your search queries. And this particular command will give you those key parameters directly, which is very useful. So it's a much more simpler command than the previous one, but it's nevertheless yeah, very important to have. So basically here you only can supply the object path that you're looking for, and also you can specify whether you just want to have the current level in the hierarchy or a different level in the hierarchy, recursively down from that point. So the use cases, of course, are you can retrieve the actually available object instances. It's part of the name. You will get the unique keys that provide fixed identifiers that you can use in future messages that you're sending to that particular device. And it also reduces quite a bit the overhead of an introspection compared to a full GET message, if you actually know what you're looking for. So if you're just interested in getting the available instances or the keys, then it's a lot simpler than doing a GET over the whole tree, which would also give you the parameter values. And on some devices, it can actually be a quite costly operation too. So that basically brings us to the recap of this webinar. So what we tried to do here is basically augment the data model in a way that retains full compatibility with TR69. So all the acquired knowledge that you've built up over the years with TR69 can be directly translated into USP. We basically haven't taken away any of the possibilities. We just enabled more possibilities, and we also kept all the shared information between TR69 and USP. So if you have already knowledge, if you already have data models, if you already have workflows, you can directly translate your already existing knowledge from the TR69 into the USP world. We also have enabled the capabilities to do this introspection, to figure out what the supported data model is in addition to the instantiated data model. So that's a feature that's only available in USP, of course, but we think it's a very useful feature to have. And through the availability of introspection, you can actually instantly determine what the device supports without any additional and in some cases very error-prone mechanisms. So there's no talking back to the vendor trying to figure out what they support. In some cases, they don't even know what they support. We have seen a lot of fancy things in that area, and we try to completely eliminate the guesswork with these new mechanisms that we have introduced. So the takeaway point here is that USP actually has the ability to reduce the friction in the field and increase the cross-vendor compatibility and adoption quite a bit by utilizing these new functions. Jason?
All right, thank you, Daniel. All right, I just wanted to, before we do our Q&A, I wanted to throw up some of the resources that you'll want to look at to investigate further. Obviously, this is Axiros' website if you want to look at any of their solutions. They have both TR69 and USP-based solutions and have been kind of ahead of the curve on a lot of that stuff. The USP standard itself can be found at usp.technology. We've published that as a web page rather than just a giant PDF of a standards document. So I saw some questions coming in about what the fault codes are for different commands. You'll find all of the fault codes on usp.technology in the specification if you go to the messages section. And I see somebody's actually posted it in the chat. I'll actually copy that and send that to everybody. So that's where you can actually find the messages and the error codes. And actually that section will describe everything that Daniel's been talking about in terms of how the requests and responses work. The data models themselves can be found at usp-data-models.broadband-forum.org. And there you will find our most recent things like device 2.13, which has a lot of new features in it, the stuff that we talked about on our last webinar. And look for the self-certification program of USP devices very soon, probably within a month or two. And it's going to be an easier to handle certification program because you'll be able to certify your own devices and then send them off. And hopefully that will take some big steps in getting the interoperability of your devices done. All right, I do want to open to questions. We have a lot of them. So if you do have a question, please type it into the Q&A box. I see some coming in on the chat and I'll try to get to those too. But Daniel, I'll let you take these as we go, but I'll call out a few if you'd rather. Yeah. First, there's a question about receiving periodic reports on the values.
Yes.
So basically, if you want to talk about bulk data collection and the push event that we just added.
Yeah, so there are different ways of receiving those kind of informations right now. So yes, we have extended the possibilities quite a bit. So while in the previous data models, you only had the possibility to basically subscribe to value change notifications. We have now subdivided that quite a bit. So you can now also subscribe to other kind of events out of the box. But in addition to that, using the new events and subscription mechanisms, we have introduced new ways of retrieving information, for instance, thresholds that you can define. So basically, you can monitor parameters on the fly, and as soon as a certain threshold is exceeded or is in between, you can get a notification. So that's one of the new capabilities that we added with this mechanism that allows us to specify events directly in the data model. But of course, as Jason mentioned, we also have the mechanisms which are also available in TR69, which is the bulk data collection mechanism, which basically allows you to say, I want to have a report of certain information in certain intervals, and you get them sent over directly without using the TR69 protocol, but you can get like a REST message or something like that.
All right. There is a question about the path for developing USP for someone who's already built TR69. And it sounds like they're talking about from an ACS or controller perspective. There is an open source agent that is being developed, has a few releases already out of from the broadband forum, and that's called OB-USPA. There isn't currently a broadband forum plan for an open source controller that in the past that's kind of been done by companies, out of band looking to do that thing. We don't have a plan for one yet, but we definitely have an open source USP agent that you can get involved with, and that's on GitHub. It's called OB-USPA. Any other ones you want to take here, Daniel?
Yeah, I'm not that quick with reading. USP, which supports USP. Okay.
There's a set of device type questions, which I think you're probably the best person to answer those.
Okay, which one do you mean?
Example of device types, also limited.
Let me take this USP question really quick.
Yeah,
so
sure.
do USP transactions use JSON-based strings instead of XML? And the answer is no, we are using protobuf instead of XML. So protobuf gives us a schema, so there's also a lot less, let's say, guesswork involved when it comes to interpreting the messages that go between an agent and a controller compared to TR69. So that simplifies quite a lot of things. But no, we are not using JSON, we are not using XML, we are using protobuf now. What else do we have? Are there any documentation which compares a specific TR69 and USP functionality? Actually, maybe JSON.
Not yet. I mean, it does exist. It's in various places. We've talked about it on a couple of our earlier webinars. We don't necessarily have like a side-by-side comparison, but that's definitely something that would probably be valuable for a lot of people. So one of the things that I would want to show in something like that is sort of, okay, this is how you do firmware upgrades in TR69. This is how you do it in USP now. This is how you do bulk data collection in TR69. This is how you do it in USP now. And we can kind of show the difference in the advantages. So yes, the information is out there. It's not all collected in one place, I guess the answer to that question.
Yeah, okay. Is it possible to instantiate more than one USP agent simultaneously for different services on the same device? I mean, should I delegate some limited remote management functions to a third party? Yes, actually, there is the possibility. but you probably don't want to have multiple USP agents, because the idea of USP is also to allow you to have multiple controllers connect to one agent. And there are lots of new functionalities specifically for that particular use case. So that's one of the reasons why I mentioned before that we moved the subscriptions into the data model. And the notifications now work quite differently, because a controller has to subscribe to notifications, rather than in tier 69, where basically the device would decide whether to send out a notification event. And yeah, you have to deal with it. So in USP, this all has changed to be completely more flexible. So you can have multiple controllers, so those can have different access controls, and those can set up different subscriptions to get only the information that they're interested in. So if you want to have multiple controllers for different use cases, that's very well possible. And if you want to restrict access to some parts of the data model to a certain controller, that's also possible. So I don't think that you will need to have multiple USP agents on the device, but yes, you could have if you wanted to.
I'm going to answer this one about why JSON wasn't chosen.
Okay.
So protocol buffers has some significant advantages in terms of the amount of it's not really compression. It's just, kind of taking shortcuts to reduce the message sizes. So that was one reason. And the other reason is that protocol buffers allows us to define the schema very clearly. So that's used with .proto files. So both endpoints can know exactly what it is they're receiving and use that schema to sort of to translate what it is that they're receiving. Those were the two biggest reasons why we went with protocol buffers.
Okay, let me take the first one here. Can you please provide some sample device types that are generated from data models in the broadband form? Maybe some samples used in real life, or should I just assume that if a device type imports a data model, it is a common case that the device having the device type will use all of the parameters of the data model in its firmware? That's kind of an interesting question, because it basically means that you actually want to use device types, which is good. So device types are a feature inside the data model, which are not that commonly used, I would say, but they are certainly very useful. So basically, instead of defining a complete data model and saying, I want to use this parts of the data model or these profiles, you can basically just pick and choose your own ones and stick them in the device type. And the device type lets you actually select the kind of features you want to represent in a specific device. And that's exactly what is also the supported data model, right? So if you put something in the device type model, that basically means you're going to support it in a way. And that's exactly the kind of information that we want to get out of the device by using the new get supported data model calls in USP. So yes, it correlates, and there are probably a lot of them out there, though I don't know of any, let's say, open ones that you can just look at. But yeah, if you want to have such a device type file, basically contact me and I can give you an example for that. Okay, what do we have?
There's some coming in over on the chat too, some higher level questions. I can grab one of those while you're looking through the rest.
Yeah, please go ahead.
The question is, are you seeing strong industry interest in new commercial models enabled by USP, by the multi-controller architecture? So a service provider outsourcing Wi-Fi optimization to one third-party provider, IoT device management to another, et cetera. Yes, very much so. And I would say that the majority of the interest that we got over the last year or so in USP has come from the third-party application vendors who want to build these things and be able to implement them on the devices. And this is actually a nice dovetail into another question I see here about enabling application and container management and these third-party applications. So these are all things that USP is very well suited for. So I would say the biggest ones that we've seen are the Wi-Fi optimization, obviously. But in addition to that, also security. We've had some sort of security service companies been very interested in implementing USP, or at least getting their application on devices that implement USP so that they can plug into the entire ecosystem. So I'm going to simultaneously answer this one about the container management. So container management itself has really always been a part of Tier 69 to a degree, and we have expanded upon that functionality in USP. And like Daniel was saying in his presentation, a lot of that functionality at the RPC level is now in the data model, which makes it much easier to interact with and change and stuff like that. So that's always been there in terms of managing the actual applications and the containers themselves. In addition to that, we have some work that we are doing that we've already started, that there'll be some press coming out about in a couple weeks about using USP to actually enable a containerized gateway internally. And you'll see a lot more about that pretty soon.
Okay. Okay, I'm going to take another one here. What is the main reason to allow multiple controllers control one agent as opposed to Tier 69? So the main reason here is in Tier 69, we have seen a lot of implementations where we actually had a Tier 69 proxy in front of the real Tier 69 ACS in order to do specific use cases like monitoring. Where basically an ACS just could not handle the amount of data that would be coming in if the device continuously sends some monitoring information over to the only ACS connection. So the main reason to have multiple controllers is simply to, well, have the ability to control your device from different controllers and implement different use cases that way. So that has a lot of benefits in terms of how you can scale your system, how you can make sure that you don't break your existing ACS implementation that's, for instance, been used for configuration of the device or for customer support. You can simply roll out additional controllers that will have access to only a specific part of the data model. And you can basically much easier roll out new use cases that way. And one thing that was also envisioned is that you can have a smartphone app in your home. So if you are at home, you can basically just get a smartphone app that implements a USP controller. You can connect to your own device, and then you can, for instance, do smart home interaction or configure the device or do anything like that. So that's only possible if you have the ability to use multiple controllers. Jason, do you have another one?
Well, so a lot of people have asked about, are there any USB compatible devices out now? Yes, there are. There have been for probably at least a year and a half now. Some of them, the early ones are obviously deployment specific. So they built them for a specific service provider who wanted some specific things and got that up and running, working right away. I know of at least one retail device that supports USP. And some of the USP things that it does talks to this particular company's own services when it comes up, and they're using USP to do a whole bunch of different things. But they're definitely already out there.
Okay, here's another one. Will a CPE which supports USP, will automation be compatible with legacy Tier 69 server, excluding very specific USP capabilities? The answer is no. So USP is a completely different protocol to Tier 69. So it is fully possible that there will be products that support both protocol also at the same time. And I know for a fact that there are such things because we have them, but there's no compatibility between Tier 69 and USP except for the data model in large parts, which is actually also a huge feature, because if you look at real world Tier 69 deployments, a lot of work is actually being spent on creating and maintaining the workflows that actually provision the device, and you know, collecting the data, transforming the data into the right formats, stuff like that. And all of that can basically be reused with a USP and maybe even simplified, but you don't have to relearn how to walk, basically. Okay.
I want to cover a couple of these that seem to be asking the same question. So they're asking about OpenACS and any open source USP controller. So I covered this a few minutes ago. I just want to reiterate it. There is no official broadband forum open source USP controller. There's no real plan for one. I expect that there might be people out there who will end up trying to build one. There is an official broadband forum open source USP agent called OB USP agent for open broadband, and that can be found on GitHub at OBUSPA.
Okay, let me take this one. Has there been any joint effort on ongoing discussions between BBF and the cable labs to extend the potentially offered by USP to the cable industry? Well, I guess I cannot comment on whether there's an collaboration or ongoing discussion, but definitely USP is going to be open to everyone. And we actually know a few vendors and companies in the cable industry that are using USP right now. So there is no obstacle to using USP for cable, like at all.
Right, and in terms of RDKB, that work is happening through members who are both members of Broadband Forum and members of RDKB, and there are interested parties that are working on doing that, but it's kind of being done through people who are already involved in both groups.
Okay. Yeah, let me maybe take this one from Mauro really quick. So they said they had a lot of problems with the capacity of the ACS collecting massive informations, and they realized that over-the-top services will not report to the ACS because of the traffic overhead that Tier 69 imposes, and whether Tier 69 will solve some of the problems without having to make modifications. Yeah, actually it will. So USP has specifically designed to do away with a couple of the drawbacks that Tier 69 has in terms of traffic overheads and the ability to transmit information in real time. So it's not session-based anymore, but it's now supposed to be permanently online, persistent connection between the devices and the server. And that allows to get rid of a lot of the overhead and transmit a lot more information in real time. And there are actually use cases that make use of that particular feature right now. So we have new interesting projects in the Broadband Forum, for instance, QED, and yeah, certain performance measurements that profit immensely from the ability to transmit much more data with much less overhead, and also get rid of the sessions that you had in Tier 69. So I think, especially for those use cases, it is very useful to use USP instead of Tier 69.
I'm answering some of these. I'm answering via text.
Okay.
Just so people know.
Okay. I see a couple of questions that are very exhaustive, so they would require an answer that is just too long to fit in the few remaining minutes.
One thing I will address, because it came in on chat, and then there's somebody else asking about Wi-Fi data elements. So somebody wanted to see what asked about the IoT support, and also about Wi-Fi data elements. I would actually recommend looking at our previous webinar from the Connected Home Council, the previous broadband forum webinar, and I can actually send that out to the people that are asking. That we went into detail about device 2.13 and the things that we added, and the two biggest things were, our three biggest things were our new Wi-Fi mesh network modeling, the ability to get Wi-Fi data elements information, and the IoT data model.
Okay. I'm just answering one in text.
Let me see
I thought your answer would be a little bit longer.
Sorry.
Yeah. It's trickling down a bit regarding to app repository, different things. OB map project, what are the fault codes? I guess we are pretty much through all the questions that we can easily answer in the Q&A section. Do you have anything from the chat?
Nope, nothing further. I think, so if you definitely have these longer questions, you want to reach out to info@broadband-forum.org. That will kind of put it in the queue and push the questions to us, and we can give you some longer answers. Someone asked where you can find the previous webinar. You can find it on the Broadband Forum website. There is a request, there's a download request form. Rhonda, you are on the call. If you want to put a chat out to everyone instead of, I don't know if I have the ability to give that to you. If you can do all panelists and all participants. She has the location of the previous webinar, or you can email us at info@broadband-forum.org, but you should be able to find it on the Broadband Forum website. But also for the IoT capability stuff, there is an extensive theory of operations that is in the most recent version of USP. So it's on the specification website if you want to go into detail about how that works. All right. Okay. And as Daniel said, that's probably the most questions that we can answer that don't require very long answers. So I thank you, everybody. There was a lot of people.
Jason, yeah. One thing.
Yes.
There's just a question that came in. Is there a plan for the date of the new release? Actually, it's all released. So everything that I've presented today and we've talked about today is already released
in the specification. Not, yeah. I don't know if are you asking about the open broadband releases, the OB USB agent releases, or are you asking about the protocol?
I don't know.
Yeah, either way.
but anyway, everything we talked about today is released, and of course we are working on the next versions of that. But everything that you saw today can be used today if you want to.
Yeah.
Okay, now you go.
Someone re-asked about the fault codes. Yeah, those are you can find those on the messages section of USP. The one thing I do want to end on is, look, we really appreciate everybody coming today. There was a lot of people here, and that's very promising. It's very cool to see that. And thank you for all the really great questions. And we definitely want people to get involved. So it's very easy to get involved with the Broadband Forum. You can contact info@broadband-forum.org to find out more information about either becoming a member or getting more involved. We love having people contribute. And there are many different ways that you can participate. You can participate in the Connected Home Council. You can participate directly in our technical discussions through the Broadband User Services work area. You can participate in the open source USP agent project, you can do that through GitHub. So please, we definitely want more eyes, and more voices are always good for us. So we strongly encourage that. So thank you, Daniel, and thank you, Axiros, for sponsoring this webinar. And please stay tuned for the next kind of thing we have coming up in this series. And we'll get that out to everybody as soon as we decide the date on that. So thank you, everyone.
All right. Take care. Bye.